Powers can also be described as roots. What a root is where your graph crosses the zero. So for instance, looking at this graph, I have a root here, I have one here, and I have one here. Again, like I said, these are also known as the zeros. So that's what they look like graphically. But when you're talking about it algebraically, and you might not be able to see a graph, a root is where b to the power of n equals x. N is the nth root. So what exactly does this mean? Well, if I were to have 4 to the power of 3 equals 64, 4 is a cube root of 64. Okay, so if we were to look at this graph here and we were supposed to find where our zeros are, these would be our roots. But with this, 4 is the cube root. Cube comes from the 3 here. So without looking at a graph, there are certain characteristics that you should be able to know without having to look at the graph. For instance, this is what we call a number of real roots theorem. I'm not too worried about that. So if we have positive real numbers, there are 2 real nth roots if it is even. And we've talked about even and odd. Even is in terms of our degree, where odd, again, is still in terms of our degree, whether it's 2, 4, 6, 8, etc. Those are going to be our even roots. There's only one real root, nth root, if it is odd. If we have a negative number, there are 0 real nth roots if it is even. There's 1 real nth root if it is odd. And this makes sense. If I were to take, for instance, the square root of negative 16. Okay, we've done this before. We've worked with imaginary numbers to know that this actually isn't possible unless you have an imaginary number, aka not real. So this would be a square root, so that'd be 2, that'd be an even. So this would classify under this property here, which we know that there aren't going to be any real roots because, again, there's a negative underneath the square root. Hence, we would have to bring in that imaginary number in order to make it true. Just kind of giving you an example here. There's another theorem that we need to talk about. That is the 1 over n exponent theorem. So when x is greater than or equal to 0, and n is an integer greater than 1, then x to the power of 1 over n is an nth root of x. All right, so now that we have all of that preliminary stuff out of the way, we've got to figure out how to actually calculate this. So for instance, I could have 81 to the power of 1/2. Okay. So what exactly does this mean? This means that I'm going to have x to the power, in this case, of 2 is supposed to equal 81. Okay, well, what squared equals 81? X has to equal 9. Because the 81 was a positive, you don't need to, generally we know that when you take the square root it'd be a plus or minus 9, but because the 81 was positive, our answer is only x equals 9. If it were negative 81 to the power of 1/2, then we would have x squared equals 81 and x would equal negative 9. Okay, that's the difference between the two. So let's do another one, because that one was a square, so it's a little bit easier to figure out. Let's say that I have negative 125 to the power of 1/3. So with this one, I'm going to have x to the power of 3 equals negative 125. So I could take a guess here and go with, okay, well, 2 cubed gives me 8, 3 cubed gives me 27, 4 cubed gives me 64, 5 cubed gives me 125. Therefore, I know it's going to be x equals negative 5 because it's a negative 25. So I've got that x equals negative 5 then. So the other good thing though is, even though I'm showing you how to do this without a calculator, if you were to have, I don't know, x to the power of 6 equals 120, you could evaluate this and approximate your solution a lot quicker if you were to instead rearrange this so it was x equals 120 to the power of 1/6. That would be easier for you to type in rather than trying to do the guess and check method. Because I'm just going to tell you now, it's not going to work out because I just threw some numbers up there. But again, this is something where you can just plug it in and get an idea. There are times when you can probably do it in your head without a calculator, and there are times when you can use a calculator. That's okay. I understand that you might not know what 3 to the power of 6 is. I get it. It's okay. Use the calculator then.